All right, today's lesson and the final lesson in this chapter is graphing linear inequalities. Now, previously we have graphed linear equations, so now we're going just to graph linear inequalities. A linear inequality in two variables is written in standard form, as you see, with an inequality sign. A, B, and C are real numbers, and A and B are not both 0. And you could also use a greater than, less than, equal to, greater than, equal to sign in place of the less than sign. An ordered pair is a solution of the linear inequality if it makes the inequality a true statement. You'll find this also on page 186 in your textbook, the steps to graphing a linear inequality. So this would be good to put in your notes. We're going to graph the boundary line. If it's less than or greater than only, the graph is going to be a dashed line. If it is less than or equal to or greater than or equal to, it's going to be a solid line. Then we'll choose a test point, and here's key. It cannot be on the boundary line. And we're going to substitute it into the original inequality. If it's a true statement that's obtained, then you shade that area. If you get a false statement, then you shade the other area. So what does this look like? First of all, we're going to graph 7x plus y is greater than negative 14. We're going to set it up as an equality. And you can use your table of values to find points. I'm not going to go over all that. We know where it's going to be a dashed line because it's just greater than. Now let's pick a point. I usually like to pick the point 0, 0. Now if 0, 0 is on the line, is on the boundary, you cannot choose it. But it just makes the math so much easier. You can do that in your head. Is 0 greater than negative 14? Why, it is. That makes it a true statement, so we're going to shade this area. Because when we pick this point and substitute it in, it is a true statement. 0 is greater than negative 14. Let's try another example. Again, do a table of values, and it's going to be a solid line this time because it's or equal to. Now let's pick point 0, 0 because it's not on the boundary. So is 0 less than or equal to negative 2? That's false. So we're not going to shade this area with 0, 0. We're going to shade the other area because 0, 0 makes it false. And any point we were to pick in here would make the statement true. Another one. Oh, look at this. If we set 3x equal to 15, x is going to be equal to 5. It's going to be a dashed line, and it's going to be vertical. X is equal to 5. Now let's pick point 0, 0. Is 0 less than 15? Why, it is. So this is the area we're going to shade because 0, 0 makes the statement a true statement. Let's do one more. Or look at a little bit more. Note that although all of our examples allowed us to select 0, 0 as our test point, that will not always be true. If the boundary line contains 0, 0, you must select another point that is not contained on the line as your test point. Okay, you are ready to begin your assignment.